All right, so in this video, I just wanted to review some words from elementary school that probably seem very familiar. The four words that I have highlighted here are range, median, mode, and mean. And in the world of math, we just call these collectively the measures of central tendency. So I just wanted to review real quick their definitions, and then I also just wanted to review how to calculate them with a few examples down below. Okay? All right, so just go ahead and take some notes here with me. I know it says up here that I was going to have you look for these definitions yourself, but since I'm not there, I figured it's easier to just go ahead and watch a video of these four words. So the first word here is range, and that's just the difference in the highest and the lowest numbers. So you find the highest, the biggest number that you see in the data set. You just subtract the smallest number you see in the data set, and that essentially gives you the spread of the data. If the range is a big number, it lets you know the data is really spread out. If the range is a small number, that means the numbers are really close together and they're really consistent. All right, now for the median, the thing here is that the numbers have to be in order from least to greatest for you to find the number in the middle. So the median is the number in the middle of an ordered data set. So we'll review just again putting those from least to greatest, and we'll talk about what happens if there's one number in the middle or if there's two numbers in the middle, what to do in that situation. We'll review that. For the mode, it's just the number that occurs most frequently. So most people just remember mode as most. And the mean is the average. And to find the average, you simply add up all the numbers and then just divide by however many you see there in the data set. Now I had a star up here for range because I just wanted to quickly address not to mix up the definitions. We're talking in this unit, again, about the difference between the largest and the smallest numbers in that data set. You've heard it earlier this school year when we talked in Unit 2 about functions. We talked about a domain and range, and we said that the domain was the list of all the inputs, while the range was the list of all the outputs or the y values. So remember, if we have a table of values and it looks like this, I had you guys identify the range before, but we're not talking about that for this unit. We're talking about the first one here again in statistics when you take the difference between the biggest minus the smallest. All right, cool. So we've got three data sets here, and we're just going to practice together and review how to find the range, the median, the mode, and the mean. And the first thing that matters is we actually order the data set from least to greatest. A strategy I wanted to share with you guys here is to just cross them out as you go along. So for example, the smallest number I see here is a 1. I have a 2. Go ahead and jot this down with me. We have a 3. We have a 4 and another 4, so I'm going to jot down 2 4s and then go back and cross those out. Boom, boom. And then we got a 5 and a 9. Now another thing I want to mention is that you can just count. We have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. We know we didn't miss any numbers. Now to find the range, again, just take the biggest minus the smallest. So we have a 9 minus this 1, and 9 minus 1 means our range is 8. Now to find the number in the middle, we're just going to go from left to right here. I've got the 1, and I'm going to undo this. You guys don't have to do this right now. You can just take, or watch me do this. I would not cross this out in your notes, but if I cross this one out, I'm going to cross this one, this, then this, this, then this. So we can see the number smack in the middle here is a 4. So like I said, I'm going to undo that. And I'm just going to circle that's the number in the middle. Now for the mode, it's the number that occurs most frequently. So here we have 4 again. We have 2 of those numbers. And for the mean, we're just going to add them all up and divide by 7. We already counted that there were 7 of them. So we've got a 1 plus 2 plus 3 plus 4 plus another 4 plus a 5 plus a 9. And I'm going to divide that now by 7, which of course is 4. So the average here is a 4. So you can see here we've got a bunch of different numbers to kind of represent the data set, and it really just depends on what the scenario is and what you're looking for, which one you would choose to use. It looks like here, obviously, the median, the mode, and the mean all indicate a 4. So 4 is a pretty good indicator of the numbers represented in this data set. All right, for the second data set, we've got 1, 2, 3, 4, 5, 6 numbers, the smallest of which looks like it's going to be this 8. Then we have a 10 and another 10. We have 2 11s and we have a 13. So Here's an 11, an 11, and a 13. Cool. So for the range, again, biggest minus smallest, when you do 13 minus 8, we get 5. To find the number in the middle, I'm just going to slash through. I've got biggest and smallest, then the next ones. Now here, see how we don't have one number in the middle? There's two of them. So in that case, I just wanted to remind y'all that you basically just add them up and divide by 2. Here, when you do 10 plus 11, that's 21. And then when you divide that by 2, it gives you the number smack in the middle, which now that you see it, it's super obvious that 10.5 is smack in between the two. But in case that this was like a 10 and maybe the next number was like a 38, it's not as easy to spot which number is in between the two. So if you just did like a 10 plus the 38, which we know is 48, but if you divide that by 2, that helps you find the number smack in the middle. So that's what you do if there's a median that's not a true number in the middle. If there's two of them, you just add them up and divide by 2. So for this one, we got the number in between them is a 10.5. All right, now the mode here, we actually have two of them. 10 and 11 both occur the same amount as each other, and they both occur more than everything else. So we have two modes here. And for the mean, we're just going to add them all up. Let me get that calculator back out. So we had, I'm going to go with 10, 20. I'm going to start with that. Plus 11, plus another 11, plus our 13, plus our 8. All right, 63, we said we had 6 numbers. So for this, the mean is a 10.5. And again, you can kind of see here that this really lines up. It gives you a measure of central tendency, talking about like how the numbers tend to behave. Thinking back to scatter plots, if there was like a positive correlation or a negative correlation, we're looking here at how data sets behave. So here we can kind of see that this data set behaves kind of around the 10, 11 area, okay? And now last but not least, we have 6, 11, 3, 7, and 8. So the 3 is the smallest number, then we have 6, then we have 7, then 8, then 11. And that's all of my 5 numbers here. So the range, biggest minus smallest, 11 minus 3 is going to be 8. The number in the middle, I've got a 3 and an 11, a 6 and an 8. So here we do have a true number in the middle, a 7. Now in this case, all of the numbers only occur once. So in this case, we'll put none or no mode. There is no mode here. And for the mean, when we add up all of our numbers, we had, it was the 6. Oh, sorry, let me just start with the ordered list real quick. It was a 3 plus 6 plus 7 plus 8 plus 11. Cool. Divide by the 5 numbers we have. You guys know that that's 7. So here we have our measures of central tendency for this data set. Now you all are going to be practicing how to find mean, median, mode, and range on your own here shortly. So that's why I just wanted to go through this. But I do expect most of you already knew how to do this and might have just needed a refresher on what to do in some special cases. Okay? Friendly reminder that you can have one mode. You can have more than one mode. You could have no mode. You could have a true number in the middle, or you might need to add them up and divide by 2. And that's what I meant by all the kind of special cases. All right, now let's flip over. And what we're going to do here is we're going to explore the mean a little bit more. We're going to talk a little bit more about the average. What I've got here is a data set for a Monday, Tuesday, Wednesday, Thursday, Friday. And this is a data set that I did make up. I did this on purpose to kind of show you guys a little bit about how some numbers might work. I did this on purpose. I called one of these places normal city, and I called another one of these places crazy city, and I did that on purpose. But first, what I want you guys to look at here and answer on your own is, do normal city and crazy city have similar weather, or do they seem to have completely different weather? Okay, just kind of look at that. Looking at normal city and looking at their temperatures, and looking at crazy city and looking at their temperatures. Do these two cities seem to have similar weather or completely different? Now, to me, it looks completely different. Okay, we're going to kind of explore a little bit what we mean by completely different in a little bit, but we're also going to talk about why some of you might think that they have similar weather, and there's actually going to be a good mathematical reason to think this, and there will also be a good mathematical reason to think this. Now, if I ask which appears to be the warmer city, Personally, it looks like Crazy City to me, only because I'm seeing like 90 here and 65 also. When I think 65, I think a nice day. 60 also is generally kind of a nice day. So to me, I'm kind of thinking Crazy City might appear to be the warmer city between the two going into this. All right. Now let's find the average for normal city, and then we're going to find the average for Crazy City. Okay. So for normal city, the first temperature we have here is a 52. I got a 55. I got a 48. I got another 45, and I got a 50. All right, cool. So that's 250. And I'm going to divide by 5. And so the average here is 50. Now I'm going to show y'all real quick that there's this symbol. It looks like that. It kind of looks like a cursive U, but it's actually the Greek symbol for the word mu. What I'm saying right now is the word mu. And that is a Greek symbol that we use in math for average. So I just wanted to kind of show you guys that now that you guys are gearing up for algebra, that the average is 50, and we can show that using that symbol. And then now let's find the average of Crazy City by taking the 65 and the 10. We've got a 25, a 60, and last but not least, that really hot day, 90. Notice that that adds up to the same 250. So when I divide it, I do get the same average. So I mentioned that I did this on purpose, y'all. I wanted us to have one place where the numbers were pretty consistent around the average, and I wanted there to be another city where you could kind of see that the 50 might be a balance for some pretty intense extremes, and 50 kind of will land towards the center of those numbers. 50 also kind of centers out. You've got like the 25 and a 65. So these numbers right here are kind of like, I would imagine a little bit more to me, kind of like there's a seesaw, and we're trying to kind of balance around the number 50 versus the number 50 here being a true kind of representation of how the numbers look. So when I asked earlier, I said, do normal city and crazy city seem to have similar weather or completely different? Well, some people might say they have similar weather because if you actually look, a lot of people will look at the average and say, well, what's the average in the two places? Kind of like right here, if people are deciding to move and people are making choices between weather related decisions, if you look at two places and you see, okay, well, they both have the same average, does that really mean up here that both cities have the similar weather? Like, no, not at all. So, yes, they might have the same average. That's a metric that might be the same. But when you look at the data set, to me, the weather is actually acting very, very differently. Now, what this meant to point out, y'all, is how consistent is our data? Is our data really consistent around the 50 like it is normal city? Or is it really spread out like how crazy city is, and 50 is just kind of in the middle, kind of balancing out those extremes? Now, some of you might have heard of this word and others might not have, but some of you might have heard of standard deviation. And what standard deviation is just trying to calculate and figure out, and this is the symbol for it, how far away are the data points from this average? Now, I want you guys to actually just put your pencils down. Okay, just put your pencils down. I do not want you taking notes on this part, but this is something that you guys are going to learn next year in algebra. And I think that a lot of times when you're in 8th grade, this is a math concept that can get way overcomplicated. And if I show you right here, right now, like how simple it can be, I think that it really helps set you all up for success next school year. Now, we already said that the average of this city is 50 degrees. So what I'm saying is that this temperature, it deviates by 2 degrees from the average. This temperature deviates 5 degrees from the average. This temperature deviates 2 degrees. This temperature deviates 5 degrees. And this temperature does not deviate from the average at all because it is the average. Okay? Now, if I find the average of these blue numbers, and again, you do not need to worry about taking notes on this, but the average of these blue numbers is essentially the standard deviation. And I'm going to show you guys in a second how that compares when we look at Crazy City. All right, so I've added up all these numbers. I'm going to divide by 5, and so 2.8. And all that means is that on average, these temperatures don't deviate very much from the average of 50. The average of 50, most of these temperatures are going to fall into a range, if 50 is in the middle, of plus 2.8, so somewhere between here, and then of minus 2.8, so that'd be 47.2. and it's just saying that that's on average how much the temperatures deviate from the mean, okay? Now, if I do the same thing over here, again, we're just trying to see how far away are each temperature from 50. This is 15 degrees away from the mean. This is 40 degrees away from the mean. This data point is 25 away from the mean. This data point is 10 away, and this data point is 40 away from the mean. So we can see that these data points are much further away than these were from the mean. Now, when I find the average of these right here, the 15, I got the 40, I got the 25, the 10, and another 40. All right, so that adds up to 130. And now when I divide it by 5, here I can see that the standard deviation is 26. So that means that on average, for the second place, if I add 26 to this, and then I subtract 26, which puts me at I don't want to 30 24. There we go, 24. So you can see that the spread of the data, the range here, is much greater than only going from about 47 to about 53. Here the spread is about 6, and here you can see this spread is well over 60. I mean, this is a very large spread in the data. So all I wanted to point out here is that you guys are going to be learning about something called standard deviation. And it does feel like a scary, intense, complicated topic. And all it's really asking is, okay, in a situation like this, if two places have the same average, if you have a small standard deviation, it lets you know that the data is very consistent. But if you have a very big standard deviation, like 26, it lets you know that the data is very, very spread out. The data is pretty inconsistent, and that the average in that situation is not a good indicator of the data. It just lets you know that the average is more like that seesaw, kind of balancing out the extremes. And in this situation, if we wanted to ask ourselves for which city is 50 a better representation, we would definitely say and conclude here that 50 is a good representative of the temperature in normal city. Okay. All right. Now that I kind of introed standard deviations for you all for the 8th grade teachers, you're going to practice on your own here, finding the range, the median, the mode, and the mean for each of these. And I don't want you to forget to put your answers into a Google form. Okay. All right. That concludes this video. Thank you for watching.